All right, so this is the worksheet for AP Calculus AB, worksheet 7-3. Here is how you do these problems. Good little summary here. All right, we're talking about a bug, and there's no calculator for this problem because I guess I can zoom to the correct size. No calculator, but this one does need a calculator. So on this one, between 0 and 8, it's crawling up a vertical wire. So I want to think of a vertical wire. I can think of some sort of bug crawling up that wire, going probably up the vertical wire. And the velocity at time t is given, okay. So graph of velocity, at what times is the bug at rest? So this one, it's going to be at rest at these 3 points because at rest is where I'm equal to 0. I don't care about any sign change. It's just equal to 0. So I'm going to say v is equal to 0, 6, and 8. Why? Give a reason. So you always have to say because velocity is equal to 0. Done. Next question. When do I travel up the wire? And assume that since it says it's crawling up a vertical wire, we assume that positive means up. And that makes sense, right? So where is velocity greater than 0? It's greater than 0 anything that has a height greater than 0. Velocity on a graph of velocity is height. So anything in that interval, so anything between 0 and 6. So we say between 0 and 6. Why? Our justification is it's because it's where velocity is greater than 0. It's that easy. All right, part C. When does it travel down the wire? Where is it negative? It's negative for that tiny little triangle, so between 6 and 8. So between 6 and 8. And why? Because velocity is now less than 0. Where does it change direction? Change direction, it has to go through the x-axis, so that doesn't count at 0. 6 counts, 8 does not count, so just here at 6. So at t is equal to 6. Why? Because v sign change. And done. Think about that as you just got 4 points on an AP free response question with those nice and easy answers. All right. Moving on to one that does need a calculator now. So I immediately see a function. Let's go ahead and put that into our calculator. So clear that one out. We have the natural log of x squared in this case minus 3x plus 3, converting the t's to x. Don't need end parentheses, but I just like to make it look nice. And our window is going to be between 0 and 5, window between 0, enter, 5, enter, and zoom 0. So as that is doing its thing, let's analyze our problem. When is the particle at rest? At rest, again, means when v is equal to 0. If you forget, it's up here as well. V equals 0 means at rest. So now I need to calculate where these happen. So again, the way that we do that, we need to calculate the zeros. So second trace the 0. So second trace 2. And my left bound is going to be 0, enter. My right bound, I'm going to enter, I think that's about 2. And, oh, that might be a little bit too big. And my guess is 1. Ah, it's x equals 1 exactly. It wasn't some weird decimal. So at t, is in this case, is 1. What about the other case? I have to do the same thing. Second trace 2. And my left bound now is going to be 1.5. My right bound is going to be, I don't know, 4. Anything between 1.5 and 4, I don't know, 2. And hey, x is equal to 2. No decimal places. It's an exact value, so 1 and 2. So 1, comma, 2. So we found them with our calculator. Why? Why are those at rest? It's because it's where velocity is equal to 0. Part B. When am I moving to the right? Well, now that we know the exact times where it hits 0, we can find the intervals. It's moving to the right whenever I'm above the x-axis. So in this interval right here, if I just hit the graph of this, I should maybe put a screenshot of this graph in the notes so we know what's going on. Make that a little bit smaller. So we know that on this graph, it's moving to the right from here, everywhere that's above. So it's moving right when t is between 0 and 1. We know that this intersection was 1 and this was 2. And anything from 2 to 1, 2, 3, so 5. Oh yeah, obviously it ends at 5. So end union that with 2 to 5. It's moving to the right. Why? Again, because velocity is greater than 0. Moving to the left, it's only that point down here where the velocity is negative between 1 and 2. So between 1 and 2. Why? It's because it's where velocity is less than 0, where the height is less than 0, where it's negative. And finally, where does the particle change direction? Well, it crosses through the t-axis in both of these cases, so both at 1 and 2 again. So I'm kind of copying down part A, 1 and 2, but the reason is different. Why is it a change in direction? It's because where it's a velocity sign change. And I'm hoping that we're starting to slowly memorize or at least connect this back to f prime sign change and stuff like that. All right, we are on to problem number 3. Are these not numbered? They're not. Okay, but this is problem number 3. I can label these as well. This was problem number 2, and this was problem number 1. And I guess I can label that as problem number 4. So on problem number 3, no calculator, it's just a graph. At what, oh, I guess we should read. A squirrel is at a building A and traveling on a horizontal wire, so I can kind of think in my mind's eye a picture. Maybe there's a building right here, a building right here, and I cannot draw a squirrel. It is now, that is a squirrel. It's traveling from building A to building B on this horizontal straight wire, and we have a graph of velocity. What times is the squirrel at rest? The squirrel is at rest whenever v is equal to 0. So here, 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 and nowhere else. So at 0, 9, and 15. So at t is equal to 0, 9, and 15. Why? It's because that is where velocity is equal to 0. Where am I traveling away from building A to the right? And that's where I have positive velocity, according to the problem, because you're traveling to the right. That's kind of defining the problem. So anywhere where I have height above the t-axis between 0 and 9. So between 0 and 9. Anywhere else? Yes, between 15 and 18. So union that with 15 and 18. And justification, because velocity is positive, it's greater than 0. And then vice versa for the next problem, left between 9 and 15 because I have this interval down here. So between 9 and 15, why? Because velocity is less than 0. And changing direction, it crosses through, not here, so that doesn't count, but it does cross through at 9 and 15 and nowhere else. So at t is equal to 9 and 15. Justification, because velocity sign change. And done. On to number 4. We'll need our calculator. I immediately see an equation. Let's plug it in. As a pro tip, especially on the AP test, you can have multiple graphs. So maybe I need to go back to this graph. So what I'm going to do is I'm going to come up here, hover over the equal sign, hit enter, and now this graph is no longer being graphed. As soon as I enter in a number, boom, now this is being graphed, indicated by, I mean, it might be different on the newer calculator, but it should somehow indicate that it is being graphed or not. And you can even graph it in a different color, I know, on the newer ones. Okay, so I'm going to do e to the power of 2 sine t. So second natural log, e to the power of, and then 2 sine of t, and the parentheses, and then end the e to the power of parentheses minus, hover over that, hit minus 1. So I now have the correct equation, and my window is between 0 and 6. Window 0, enter, 6, enter, zoom, 0. Okay, it's graphing that function. Let's go ahead and analyze our problem. When is the particle at rest? That is where v is equal to 0. That is when it touches the t-axis in this case. So I have, it probably touches the t-axis over there. Does that make sense? When I plug in 0, sine of 0 is 0, 2 times 0 is 0. E to the power of 0 is 1, 1 minus 1 is 0. So yeah, that does make sense. So here and here, these two spots. I need to figure out what that spot is though. So I know one of them is going to be t is equal to 0 just by my mental math, but I could check that with my calculator. The other one, I'm going to do second trace to calculate the 0. So second trace 2. My left bound, I'm just going to randomly say 2, enter, and then 5, enter. Anything between 2 and 5? I don't know, 3. And it tells me right here at 3.14159. Sounds familiar? It's pi. Okay, so on the AP test, you can enter pi if you're being super cool, but a little bit better, you can just round it just in case it was maybe off at the 1000th digit. I don't know. Well, I think it'll still be fine. You'll get points either way. 3.142, 3.142, and I'll make a note in here, that's just pi.
Okay, let's do that one.
Yes.
Is that I'm graphing it on my calculator and it looks like the same graph that you drew, except for it's like 3 above where it should be.
3 above.
I got something completely different.
It's like, I don't know. It's
Ooh, maybe I messed up in my function. Let's come back over here.
'Cause I think I don't know.
E to the 2 sine of x, n parentheses, minus
Is it the one outside?
1.
No, the one is still
Is the one
to the.
All right, so we have that graph. We have those times that the particle is at rest. We need to give an explanation. That's because, oh, I need to switch back to blue. That is because time, curly t, is equal to 0. During which time intervals is the particle moving to the right? That's anything that has a positive height. So it's between 0 and pi. I'm just going to use pi because I think it's more accurate. So between 0 and pi, and that's when it's moving to the right, and justify because that's where velocity is greater than 0. Where is the particle moving to the left? That's anything down here, so pi to the end of the interval at 6 here. So from pi to 6, between pi and 6, why? It's because that's where velocity is less than 0. And I should really copy and paste this graph while I'm at it, just to have some good notes for later. Paste that in there, make that as large as I can without hiding some answers. Cool, and then from there, at what times does a particle change direction? The particle changes direction when it crosses through the x-axis, so not here at 0, but definitely at pi. So at t is equal to pi. Why? It's because you have a velocity sign change. All right, that concludes worksheet 7-3.